When I first attempted this question, I struggled a bit to come up with the necessary assumption that the question has asked for. Because when I try to analyze this question, n, which is 8, it is small, and I know whenever n is small, I need the population to follow a normal distribution, which is already given to me by the question. What I do know next, it is when n is small and the population follows a normal distribution, I have to decide whether I'm going to adopt a z-test or a t-test. What this question wants is for us to carry out the test by making use of a t-test. And that is why I've concluded that the best possible assumption that we can make is probably to assume that the population variance is unknown. Because once the population variance is unknown, we will go for a t-test. If it is known, we will actually go for a z-test. So I'm assuming that the population variance is unknown, and now let's try to carry out a test at 5% level of significance. I'm going to quote the hypothesis, H0. H0 is given to me as 13.8. The distances traveled, it is 13.8. And what the editor believes is that the distances traveled are too high. So the challenge, the alternative hypothesis, is that it is supposed to be less than 13.8. With this, I'm going to next quote the three parameters that we have discussed in our outline. First, the sample size. In this case, sample size is 8. Next, the evidence that we have collected from these 8 samples, and that is x bar, the sample mean. From part 1, the sample mean has been calculated to be 12.8. Then, the population variance. I do not have the population variance, so we have to compromise by stating the unbiased estimate to the population variance. And again, from part 1, we're writing this to 5 significant figure, 2.3057. Then I'm going to write down the test statistics. This is going to be a t-test. So it is going to be a t, which is equal to x minus the population mean 13.8 divided by square root of the population variance 2.3057 over the population size of 8. And this is going to follow a t distribution with a degree of freedom that is n minus 1. So 8 minus 1, 7. With this information that is given, I can now press it into my graphing calculator. But before that, maybe you can do a quick check to just make sure that I have quoted the hypothesis correctly. According to what we have discussed before in our material and the questions that we have given, I always encourage students to do this quick check whenever it is a one-tail test, left tail or right tail. Because when it is a one-tail test, we can actually verify that the inequality sign here is definitely correct by looking at the evidence that is given. In order for us to carry out a hypothesis test, we must always make sure that the evidence that we have collected supports the alternative hypothesis, or else there's nothing to test. And what we have here, my evidence shows that the average distances that is traveled is 12.8, and this supports the alternative hypothesis. That is why I'm very, very sure that the inequality sign here that I've decided is correct. So anyway, it is just a very quick check that I will always encourage students to adopt. So with this that is verified, I'm going to now press into my calculator to extract the p-value in order for me to come up with a conclusion. From my graphing calculator, the p-value that I have obtained is 0.0524. And now we can conclude, because this p-value that we have obtained is bigger than 0.05. So we concluded that there is insufficient evidence to support the magazine editor's belief at 5% level of significance.